Hi everyone, Peter here from Flow High Performance, and in this video we'll be exploring the idea of dynamic effort reps and their application to maximal strength training. First, we need to establish what exactly is meant when we refer to dynamic effort strength training. As far as I'm aware, the dynamic effort term was created by, or was popularized by Louis Simmons. He refers to this term in his book West Side Barbell Book of Methods as lifting submaximal weights as fast as possible. He also states that when doing this form of training, weight should be used in the 50 to 75% range of the lifter's 1 rep max. It should also be noted that Louis uses this training method in the classic squat, bench press, and deadlift exercises for the goal of transfer to maximal strength. So essentially, dynamic effort training simply refers to lifting loads of 50 to 75% 1RM as fast as possible. Although Louis Simmons doesn't explicitly state the exact adaptations that this form of training is attempting to provide, his book states that being fast and strong are more closely related than you think. So the presumption is that if a trainee can move a lighter weight faster, then it should allow absolute heavier weights to be lifted. It should also be noted that Louis Simmons generally recommends the dynamic effort training to be alternated with heavier lifting sessions, rather than being performed alone. To understand if dynamic effort training can enhance maximal strength, we need to take a look at the force-velocity relationship. This relationship shows that the less force that is required, the greater the velocity will be if moved as fast as possible. In opposition, the higher the force requirements of an exercise, the slower the velocity will be, even if moved as fast as possible. This can be understood simply with the example of a classic squat or bench press exercise. The heavier the weight is, the more force that is required to move that weight. However, a heavy weight cannot be lifted as fast. If we use a very light weight for the same exercise, we don't require as much force to lift the weight, although it can be moved much faster. So maximal strength would sit all the way at this end of the force-velocity relationship because we are trying to produce as much force as possible to lift as heavy of a weight as possible. There is absolutely no regard for speed when referring to maximal strength. It doesn't matter how fast the weight is lifted, it matters how much absolute weight can be lifted. The dynamic effort method would sit somewhere here on the relationship, where force is moderate and velocity is moderate too. Let's now have a look at the principle of specificity, which determines transfer of training to performance. The principle of specificity refers to the fact that the more similar an exercise is to the competition exercise, the more transfer it will have. So if a trainee performs the bench press with heavy weights and low reps, they are more likely to improve their 1 rep max than someone doing lighter weights even with higher reps. So when we have a look at the dynamic effort method, it uses the same exercises as the competitive power lifts, although the force requirements are much lower than a 1 rep max attempt. Therefore, dynamic effort training is less specific than traditional heavy strength training. Another potential reason that dynamic effort training could potentially be useful would be for hypertrophy purposes. If hypertrophy can be achieved, it would likely enhance the potential for maximal strength, since there would be more total contractile units to recruit. Although hypertrophy training can be achieved with lighter loads, hypertrophy training is best achieved by taking the sets fairly close to failure, which isn't achieved with dynamic effort training. So it seems that dynamic effort training doesn't necessarily have any direct benefits over traditional strength and hypertrophy training for maximal strength gains. However, there could be some potential indirect benefits. If a certain lift is trained multiple times per week, and the trainee is training multiple lifts simultaneously throughout the week, then the total workload can potentially cause unnecessary fatigue accumulation. If these lifts are trained hard every time they are performed, then it may simply be too much training to recover optimally from. Dynamic effort training may have a role in serving as a light session while still practicing the technique of the exercise. So rather than doing a hard hypertrophy session or a heavy strength session, the dynamic effort method can be used to allow fatigue reduction while still staying in touch with the exercise. So when a heavy session then needs to be performed, the trainee can feel less fatigued and could potentially lift heavier loads. Another common conception is that doing fast reps with lighter loads is better for power output, which has benefits to actions such as sprinting and jumping, as required by other athletes in various sports. So dynamic effort training may be beneficial for such athletes. While it is true that faster reps with lighter weights do have a higher power output than slower reps with heavier loads, it fails to consider the muscle actions of athletic movements. When jumping or sprinting, the muscles are used in a ballistic fashion, which means there is no deceleration phase during the propulsion of the movement. Let's take jumping for example. Once the athlete propels himself off the ground, their entire body moves in that direction. The muscles don't stop producing force until their feet leaves the ground. This is not seen in traditional strength exercises, since the bar must ultimately come to a stop at the end of the range of motion. For example, in a squat, the body must decelerate at the top of the lift because the athlete's feet don't leave the ground. However, during a squat jump, the athlete goes into a complete jump, meaning that this is a ballistic movement. So even if the power output is higher during dynamic effort lifting, it is unlikely to have much transfer to athletic performance due to the unspecific muscle actions. Athletes are probably better off doing jumps, sprints, and throws to develop power rather than barbell strength exercises. So what can we conclude practically from all of this information? First and foremost, dynamic effort training probably doesn't have great direct transfer to maximal strength performance. It also isn't great for hypertrophy training since it doesn't go close enough to failure to promote muscle growth. It also isn't the best option to develop other athletic qualities since the muscle actions are fairly different. However, a benefit it may have is to be used as a light session to aid recovery. This can allow technique practice with minimal induction of fatigue. Thanks for watching and hopefully you got something out of this video. Remember to subscribe if you haven't already.